Hi guys, today we will continue our problems on isomorphism. We have already discussed this problem online, but still I want to discuss this problem. So these two graphs I call them as G1 and G2. Okay, we have these two graphs. So the question is, are they isomorphic? Okay, so last class I had told you that we have 5 points. The first point is that number of vertices in both the graphs. So we can see here that both the graphs have like V1 to V8 and here U1 to U8. So both the graphs have 8 vertices. Okay, so both the graphs have 8 vertices. So this first point is satisfied. Second thing is number of edges. How many edges are there? You can see there are 10 edges in both the graphs, right? Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And even in this graph the same. So here outward 4 and then here we have 4 and we have 2 more, totally 10 edges are there in both the graphs. Okay, then the third point is number of vertices with a given degree. So both the graphs have like 1, 2, 3, 4. 4 vertices with degree 2, 1, 2, 3, 4. 4 vertices with degree 3. Okay, and what about this graph? In this graph 1, 2, 3, 4. These 4 vertices of degree 2. 1, 2, 3, 4. These 4 vertices are of degree 3. So both the graphs have 4 vertices of degree 2 and 4 vertices of degree 3. Okay, that was the third point. Then comes the fourth point. So in the fourth point, what should we discuss now? So in the fourth point, we have to do the mapping between the vertices. How to do the mapping? Something seems to be wrong here. Because see here what do we have? Like U1, U6, U5, U4. These vertices are of degree 3. So here like adjacency U1, U6 are adjacent, U6, U5 are adjacent, U5, U4 are adjacent, U1, U4 are adjacent. Right? 4 pairs of adjacency is there among the vertices of degree 3. But here if we see V4, V5, V7, V2, these are vertices of degree 3. V4, V5 are adjacent. V7, V2 are adjacent. So only there are 2 pairs of adjacency between the degrees of the vertices of degree 3. Okay. And the other reason we can say is about cycles. So what do we mean by a cycle? Cycle is, for example, as of now I will tell you cycle definition I will give you in detail later. As of now I will tell you that this V5, V6, V7, V8, V5, this is a cycle. Similarly, V4, V1, V2, V3, V4, start from one point, go to the other vertices and edges, come back to that point. That is called as a cycle. So here there is a cycle. See V4, V5, V8, V7, V2, V3, V4. This is a cycle here. What is the length? 1, 2, 3, 4, 5, 6. Okay. So there is a cycle of length 6. Actually we have another cycle. There are so many cycles. Okay. There is one cycle. Actually there is another cycle you can see. V4, V5, 1, 2, 3, 4, 5, 6. Okay, there is another cycle of length 6. But what about here? Can we find any cycle of length 6 here? If you take this 1, 2, 3, 4. Length is 4. If you take this 1, 2, 3, 4, 5, 6, 7, 8. No. So actually whichever cycle you take in this graph, there is no cycle of length 6 in the second graph G2. Okay, so this reason also we can say to say that these two graphs are not isomorphic. So we can say that this graph G1, it has a cycle of length. It has a cycle. Actually it has 2 cycles. We can mention that also. It has 2 cycles of length 6. Okay, but G2 does not have any cycle of length 6. Okay, this reason we can use to say that these two graphs are not isomorphic. Then going to the next graph. This graph already we have discussed. Okay, next coming to this graph. When we come to this graph, one thing we have discussed that I have already told you, isomorphism is like the same graph. You are just elongating some edge or you are twisting the graph. Some structure is there, you are twisting it, you are turning it. Okay, it is the same thing in another shape. Okay, which looks different. Okay, content, everything is same. So that kind of a thing. So here if you see, like these two graphs if you see this outer structure what we have, U1, U2, U3, U4, U5, that is seen inside this structure. Okay, pentagon kind of a structure, you can see that inside. Then this star what we find here, right? This star what we find in the first graph, that star is seen outside here. That means it is like twisted inside out. Okay, whatever is there inside, it is outside here. Whatever is there outside, it is inside here. Then connection between these corner vertices, that is there in both the graphs. So if we imagine it is like something is there, we are twisting it. Okay, so these two graphs seem to be they are isomorphic. So if you see the number of vertices, both the graphs have 10 vertices. You can count U1 to U10, V1 to V10, 10 vertices. Both the graphs have 15 edges because outside 5, star 1, 2, 3, 4, 5. Star also contains 5. Then these lines, okay, so 15. Similarly here also 15 edges are there. Every vertex is of degree 3. In both the graphs you can check, whichever vertex you check, it is of degree 3 in both the graphs. Okay, both are 3 regular graphs, cubic graphs. Now, how to do the mapping between the vertices? Let's see. See, as I said, actually we can do the mapping in many ways. The easiest way is keeping this outside structure inside. So, what we can do now? Map U1 to V7. Okay. Then U2 is V8. And then U9 is U3, okay, U3 is V9, then U4 is V10, and then U5 is V6, and then U6 is here. This star is outside, okay, so V5, fine, U6 is V5. And then U7 is V1, right? This U7 is V1. And then U8 V2. And then U9 is V3. And then U10 is V4. Okay, so this is the mapping between the vertices. So using this mapping between the vertices, now we have to write the mapping between the edges. So let me write few things. One, suppose I take this U1, U2. What about U1, U2? The edge U1, U2 is mapped to. U1 is mapped to V7, U2 is mapped to V8. So there must be an edge between V7, V8. Do we have? Yes, V7, V8. Okay. And then, suppose I take U1, U7. U1, U7. What about U1, U7? U1 is V7, U7 is V1. So V7 V1, V7 V1. Okay, V7 V1. Then what is the next one? Suppose I take, okay, randomly I am taking, you have to write it for all the 15 edges. Suppose I take U6 U9. U6 U9. If your mapping between vertices is wrong, this edge mapping will go wrong. U6 U9. U6 is V5. U9 is V3. So V5 V3. Where is V5 V3 here? V5 and V3. Okay, so V5 V3, there is an edge. V5 V3. Okay, so you have to write this for all 15 edges. So these two graphs are isomorphic. Okay, thank you. That's it for now. I'll come up with more videos. Thank you.